Please welcome our next speaker, Antonio.
Sorry for being late first, but at least I'm warm up, so this probably will work. Okay, so first thank you for inviting me to speak here. My name is Antonio Perić-Mažar, and of course it's a pleasure to be here. I just want to tell that for people who didn't attend on conference track, for me it was amazing, so next year be sure to be there. So, I'm from Split, I'm CEO at Locastic, and I'm working web development for like 8 years now, I think. Mostly I'm doing in Symfony, but for last 2 years I'm moving more into way of user experience things, some front-end things and things like that, like more business things, I'd say. Also this year we founded Blockada, that's a non-government organization, was founded by Bruno Tomislav, who is not here, and me. And we are organizing 2 annual blockchain events. I will mention that at the end of the conference. So if someone interested in that, feel free to ask us anything. Okay, a few words about Locastic. We are in market since 2011, and we are doing mobile web development, user experience, and training and consulting. We also started the Shift conference in Croatia. We did Symfony Croatia meetups for a while, but we stopped that. At the moment, we are doing Tinel meetup for 1.5 years, and we are hosting like worldwide no speakers from all parts of the world. The fun fact about us is that we are actually owning the Counter-Strike team. So if you want stickers, I have some of these here. And also the fun fact is that after 5-6 years, we have a team that can compete with Serbian teams because we are much stronger in Counter-Strike scene at the moment. So yeah, we are very proud about that. What I want to talk today is about service workers, but we cannot talk about service workers if we are not talking about user experience on web, but on mobile user experience. So if you ask like your users, what are the 2 most important things for them in their life? Like they are not coders, they are your users who are giving the money for your salaries and your companies, of course. So the first thing will be mobile. Second thing will be user experience, and that's period. The 2 most important things. Why? Because we all have mobile phones, right? So yeah, we are using that every day, and we want easy user experience. We want to use it easy. So let's see some stats before I start to working about technical implementation. By 2020, more people will have mobile phones than water or electricity. This is like a bad thing for us as humans, but that's what stats says. And if you are talking about speed of the connection, you will usually think that the lowest or poorest connection are in Africa or something like that. That's not true. Like the most of 2G connections are actually in the United States. So we need to think that in a way of user experience. In 2016, we started to do more search on our mobile devices than on desktop. And in 2017, we already served the half of our data to the mobile devices. And we all know that the data on a mobile is expensive. So if someone from Croatia is here and doesn't have the Serbian SIM card, you know how data is expensive. Like 6-7 euros per 100 megabytes, not gigabytes. So yeah, that's a huge amount of money. And how users are using our data, our apps. They are 82%, actually 87% of their time, they are spending inside their mobile apps. Not on web applications, on mobile applications. And that means that fundamentally, mobile web experience is broken. That doesn't work perfectly. That doesn't work well. And that's the problem. And that's something that I want to talk with the service workers. But before we go further, this is like from the book, Effective Writing Code Without Writing the Code. And there is the chapter about user experience. So if you are not giving the free music or free porn movies or something like that, you don't have a big cheese. So you need to have perfect user experience because the user experience is this electric grid and this is the graph. So the bigger cheese you have, user will suffer from over electricity shock, but usually you don't have the big cheese. For example, the big cheese was possible for ICQ, but today when we have WhatsApp, we don't want to use something like ICQ, right? So trust me, you will never have enough piece of cheese. So you need to invest in user experience. And sorry, I have some kind of the flu for the last 2 days. So, and this is from Jeff Thetford. He actually wrote that book, and he's co-founder of Stack Overflow. This is the thing that you need to have in mind as developers. You need to take care about user experience. You need to take care about your users. I don't care if you are front-end or back-end developer. This is the rule number one. I don't care about your architecture. I don't care about your UML diagrams or whatever. I care about user experience, and user experience is hard. That's the hardest part of application. So yeah, let's move to progressive web apps. You probably heard, how many of you heard about progressive web apps? Okay, more than on my last talk. So progressive web apps is not something new. It's actually here for 3-4 years. It gives us possibility to build mobile user experience using web technology. Why that is important? Because of this. This is the graph of capability things, and this is the reach. So this is the mobile apps. They have huge capability. You can access to your camera, you can access to your Bluetooth, you can access to wireless, you can access to whatever you want, basically. And on web, we have huge reach, because 90% of the reach that we have on internet is actually on the web, not on mobile apps. We have better security on mobile web applications. And we don't have capabilities. And progressive web apps aim to do this. To have capability to access to all the hardware features of your mobile phone with the reach of web. So that's are the goals of the progressive web apps. So let's define them in one sentence. So progressive web apps use modern web technologies to deliver an app user experience. So the keywords here will be modern web capabilities, app-like user experience. So with existing web APIs, HTML5, JavaScript technologies, we can deliver app-like user experience. That's what progressive apps are. So what that means? That means they are progressive. They work for every user, regardless of the browser, because they are built with progressive web technologies. They are responsible, fit to any screen. They are connectivity independent, works offline. They are app-like, so you don't have any difference in using your mobile web app or your web app. They are fresh, your data is always up to date. They are safe, using only HTTPS protocol for giving your data. They are discoverable, you can find it on your home screen, you can find it on browsing to the websites. They are re-engaging, that means we can use push notifications in progressive web apps. And of course, they are installable. That means you can install them on your home screen. And that's the huge feature for web apps. Of course, you can share them as a link. This is the core stack for progressive web apps. So we have HTTPS protocol, we have service workers, we have web app manifest. Web app manifest allow us to add our web application to home screen. And this is some additional API that we can use, but we don't need to have. So there are 4 main things to focus on when we are talking about progressive web apps. They need to be fast, they need to be integrated, they need to be reliable, and they need to be engaging. So what that means, they need to be fast. It means there is no junkie scrolling. It means you serve them really, really fast. It means that bad connection is not your excuse for anything. What means fast? It means that 53% of your users will abandon your website if it takes more than 3 seconds to load. 1, 2, 3. That's like a lot of time, right? But compare this. This is 1 second. This is 3 seconds. And this 3 seconds seems like a lot of time, like forever. This is really slow. It's just 3 seconds. And this is how web should work. So how to do that? We have first pattern from progressive web apps, which is in core is, you will see later how it is made by service workers. It's app shell model. It's the same how your native mobile application works. So you have all the designs downloaded and cached for the users, and then you are just fetching the data to the designs. So user doesn't need to download this image, this URL, navigation, and things like that. He will just get the title and some content. In that way, we save a lot of time to load our application with data. So app shell model allows us to have reliable performance, native-like interactions, and economical usage of data. This last thing is the most important because it saves the money. So that's the most important thing. So the next thing is integrated. That means user, when he's using our application, it should use it in the same way as any other native application that he's using. So he needs to be able to install that to the home screen. He needs to be able to launch that from the home screen. And he doesn't need, or actually he must not need to see the browser bar because we want the feeling of the application. So this is the universe of our mobile app. This is the center of the universe for us. It's our home screen, like Sanctuary Place or something like that. But how many of you actually installed free applications in last month? 2 applications? 1? So basically, it's like a third of people installed free. Sorry, I asked in the wrong direction, but actually it will be like this. It's usually like this in all talks. So actually only a third of you installed free application. You're probably not using even one or something like that. A lot of people doesn't even install any application on their mobile phone. And if we are installing something, it's usually this. So Google, Facebook, YouTube, Twitter, and things like that. Actually, we are removing Facebook lately a lot. What's the other problem? The process of installation. Users are, I don't want to say any offending word, but users are forgetting what are they doing through the steps. So if you have 800 users that actually went to store to download your application, 600 will find that application, 500 will install, 400 will accept, 300 will download, they will forget, and only 250 will use your application. That's like 20% of the users who had the intention to download your application never used it, and you need to spend a lot of money to develop like at least 2 versions of mobile application. You need to maintain them. And 80% of users will actually intentionally move apps to the home screen. Why? Because they use that application often. They have interest to use that application, and a lot of them will put the application to the home screen because the logo looks nice. So that's why people are putting that on the home screen. And we could do that with the web, but this is how it works now. So you need to go to some settings, you need to find add to home screen, then you need to add it. Like nobody will do that. Like did anyone did this? I did twice, for example, so 3 people. Yeah, so this means that user experience on the web is really broken. We need to improve that. We have web manifest file. It's not related yet to service workers. It will never be related to service workers, but it's simple JSON file where we described how our application works, how it can be downloaded to the home screen. And that's it. This is what you need to have to define the JSON file. And you can do this now. You can add this to your home page. It won't work actually because you need to have service workers and some offline capabilities to get installed to the home screen, but this is the starting point. You can debug it to the inside the Google Web Developer Console, and we have perfect user experience, which works like this. So you go to some page, you got engaged, and you got 1 click to add this application to your home screen. And see next, when he runs the application, there is no browser bar there. So there is 40% more interaction if application is at your home screen. Okay, before the main chapter of service workers, I want to mention Web Payment API. This is like, I think from my perspective, this is the point where the user experience for mobile web is the fucked up. Literally. Like 60% of the purchase on mobile are from the web. So 66% of the purchase are from mobile web on your mobile devices. But from all the number of the purchases of the online, only 1/3 is from mobile devices. And that means that user experience doesn't work. In the fashion industry, actually at the moment we have 60% of the purchases done with the mobile phone. But that still doesn't mean that user experience is good. So, what this means, this is checkout forms today. Like, you go to the checkout process, and then for 30-45 seconds. It's slow, it's end taps, it doesn't work. We improved that with autofill. So we have 30% faster, it's some kind of automatization. Still it's slow, still it's end tap, but it's still 30% faster, and you can implement this very easily on your existing application. And Web Payment API is something that will make us forward. Why? Because it will work like this, 1 click. So you will get this message, or this message, and you will click pay. And how it works, you as developer, you will call payment request. Your browser UI will collect the payment. It will be success or failed, and you will show the message to the user. This is actually the flow. So you show the payment window. If user cancels, nothing happens. If payment's complete, you get the payment done. This is not payment gateway. This is just something that we can connect to the payment gateway with one click. And this is how it works. So you just go to proceed to checkout. You will get this window. You click pay. You can integrate this with the Google Pay already and things like that. So it's one-way click to pay, to complete your payment. We have some other APIs, like media session APIs. You probably saw this to your native apps. We have web share, so we don't need to use any more third-party libraries to share. And you need to remember that users expect to be able to interact with your app with any kind of native apps that they have on their devices. And then let's move to reliable. And this is the part where service workers are changing how mobile web is working. So the first thing that we need to remember about reliable things is that never but never showing the dinosaur. Like never. People hate this. Even if you have Wi-Fi, you know what's Wi-Fi? When you see that your signal is full but your internet is not working and you are like pissed off because of that. And there is no, this is all the list of the excuses, but that doesn't work. Users doesn't care if there is power outages, if there is extreme weather condition, or if he is traveling through the tunnel. He wants to see some data. And we need to enable that. So we need to enable instant loading offline. And we need to have in mind that 60% of mobile connection is 2G. And the fast web is the #1 rule for user experience. And this is the stats at the moment. We have 40 seconds on 4G networks to load the website, or 90 seconds on 3G. That's like, whoa, that doesn't work. That's not good. That's like, we don't think about things that we are producing as developers. And that's something that we need to change in our minds. Okay, so service workers. What is the service worker? Service worker is actually the proxy between your server and your web application. It's separated thread, which is not the same thread as your web page, and it works as a proxy. So if you know what's the proxy, so all the requests go to the server worker knows how to handle them. So this picture is even better. So application will request something, it will go to the service worker will take something from the cache, serve to the application, or if there is nothing in the cache, he will serve something from the network. So he lies between the web application and network and cache. It allows us to have rich offline experience. We can have background syncs. We can have push notifications. We can have almost all the things that we have with native applications. As I already mentioned, the script that browser runs in the background separated from the page, that is service worker, and it's JavaScript. So the same JavaScript that you are using for show hide or things like that, you will use that for service workers. Usually I got the question like, does it drain the battery? No, it doesn't drain the battery because he's sleeping until you send some event that will wake him up, and he will do some of the work. Okay, the life cycle of the service worker is this. You need to include service worker to your page, and once you request it, he will start installing himself. If installing script fails for some reason, we will get some error and he won't be activated. If everything goes to the installing, he will be activated, he will go to sleep and wait for our messages. This activated we will see later. It's usually used to clean up the cache from the previous service workers because for a scope, the scope is part of the URL. So if you put the service worker in the root of your website, the scope is entire website. If you put the service worker inside /blog, the scope is /blog and everything that goes after that. So this is how we put it in the code. I hope you can all read it. So first we check is service worker available for our browsers, because at the point some browsers are still not supporting service workers, but that's slow. That's changing faster than we expected probably. So on the load event, we want to register some service worker, sv.js. If everything is okay, we can console log the message, everything is okay with that scope. If something fails, we can log the message. Of course, we can use console to check our service workers who are running. We can stop them, we can restart them, we can unregister them, we can update them, we can do whatever we want. There are some service worker events that we are using. So it's on install as dependency, on install not as dependency, on activate, on user interaction, on network response, state while revalidate, on push message, on background sync. Depends on your use case. I will show you some of caching strategies. On next slides, you need to define how to use the service workers events. So basically on install as dependency, so you start your service worker. In install event, you will load all your static files, like CSS files, some small images, CSS files, and things like that. And that's how app shell model is actually built. Because in this situation, we have all these files cached. We don't need to request to server like 10 requests or 15 requests to get all the static files. We have them on our hard drive, and we can serve that directly to the user. And code for this is pretty simple. So we listen for an install event. This event waits to complete all these things. And if something fails, our service worker won't be installed. But on next request to the web page, he will try to install himself again. And you need, of course, you need to manually add these things. You need to manually define what do you want to cache. And after you do that, on the next fetch request, this will be served from the cache. We will see that later. We have on install not as dependency. As you can see, this looks the same, but the only thing is that you won't wait for, if in this situation you won't wait for installation to complete, you will load some files later, and usually you will load some bigger files, and that's how you will cache them. So the code is almost the same, but as you can see, we are not waiting for this one to complete. Updating the service worker is something, it's like you need to know how it works. So basically when you are change line of code or anything in your service worker, the browser will download the new service worker. When the new service worker is downloaded, he will go to install event. He will try to install yourself, but still he's not activated. Because the existing service worker is still controlling the pages which were open in your tabs and things like that. So you need in some way to wait for the new request or to close all the pages or to skip that in some way. So install event will be fired. Old service worker is still controlling the pages, and until all the pages that are open, the old service worker is still controlling them. But we have this situation here, that once the new service worker is activated, we got this event. So when he is activated, we got this event, and we can clear all the old cache, and of course, add new things to the cache. I probably removed that from the slides. You actually don't, okay, here's the code I didn't remove. So this is the code. So for example, on activate event, I want to find all the cache that are related to the previous service workers, remove them, and use the new cache that I filled in with in install event. Usually the trick here is to have constant variable with version of your service worker, and then you just map all the cache with that constant. And if you don't want to wait, you will just use this. Self skip waiting, so your new service worker will become available immediately and take control of the website. The user interaction. So what's happening when the user interacts with your website? User clicks on something, and then service worker go to network and cache something. This is just the basic example. Like we want to go to the network. Once the network responds with something, we want to cache that. It's very, very simple. It's ideal for situations where we cannot put offline entire web application, but we can put articles, for example, and then we can have ability to read later or save to offline. And when our user go offline, he will have like YouTube video or Wikipedia article available to read without network connection. The code again is very simple for this. Like we need to download the data from the network, open the cache. Open the cache, fetch the data from the network, save that to the cache, and next time we will serve that to the end user. This is the similar one. So on a network response, we see the user requires, again, requests go to the server worker, go to the network goes to cache, and that response go to our user. This is useful for inbox, for example, like Gmail, if you are using that, for example. You can cache the data and show it to the user when they are offline, but if you want to get new emails, you will show that to the network. So if your user is traveling or something like that, he can still read his emails, and he will get update once he reaches the network. The code for this, like you need just to have in mind, this is all part of the fetch API. So all the events that are catching the user interactions are fetch events. And you need just to prepare logic that you want inside it. When to put in a cache, when to load from the network, and how to do that. Statewide revalidate is usually used when you want to show something fast to the users, but you also want to update new data from the network. And this is used for avatars, for example. It's not critical for me to see last version of your avatars, but on next refresh, next request, it will be nice to have them. So you can use this. From the cache, it will be served immediately, and you will update the new version for next request. Code, again, the codes are always similar. So on fetch, we will serve something from the cache if exists, of course. If it doesn't exist, we will get that from the network and save to the cache. Background synchronization event is for non-urgent updates, which are maybe bigger than some things like this. For example, leaderboards or things like that. And sync events is triggered when your user goes online. So for example, if he goes online, you can sync his data in background. He doesn't need to be aware of that. Once he opens up, even offline, you can show all the data to him. And you can see that here the listener is a sync. It's not the fetch event. And in the next part of the talk is serving suggestions, how to respond to the request. So we have cache only, we have network only, cache falling back to network, cache and network race, network falling back to cache, cache the network, and generic fallback. The first one is the simple one. It's part of the app shell model. So serve everything from the cache. So you will serve all the static files in your cache, you will serve them, and you need to be aware to take care about that you store to cache everything in your install event. So the code is quite simple. On a fetch event, find it from the cache and just respond it. Of course, this will return unresolved if you don't have anything in cache. So you need to have in mind to cache that before you are using that in install event. Network only is how most of web application works. So nothing will happen. The service worker will just respond with network response. And this is used when you don't have any alternative or equivalent for offline data and for non-GET requests. So put, post, and things like that are using here. Cache and then falling back to network. This is ideal when you are building offline first, and this is how you handle majority of your events. So what you will do here, you will go to service worker. If there is nothing in a cache, you will go to the network, and you will give the user response from the network. So that's how like all the offline first application works. And you need to be aware that if you have new data, you need to update the cache by yourself, of course. The code, again, is a simple. If there is anything in a cache, just fetch it from the network. If there is something in a cache, return that. That's basically it. Cache and network race. Not something that is very useful, I will say, in modern world, but still we have users with slow hard drives, with virus protections, firewalls, and things like that. So serving some small assets will be maybe faster from the network than from the cache. So basically, you send parallel requests to the cache and to the network, and which responds first, you will serve that to the users. This is like really not something that happens often, because usually you have SSD disk or something like that in 21st century, so it will be served from the cache. And you need to have in mind, again, that if you are serving through the network, you are spending the data from the users, because mostly we are talking about mobile users. This is the code. This is just, it says here, There is function that is called promise race, but it doesn't do good. So this is the same thing to return anything that happens first. And in promise any function, we call cache match or fetch from the network. Which responds first, it will be respond to the user. Network falling back to the cache. This is ideal for quick fix for the resources that are updated frequently outside of the version of the site. However, you need to have one thing in mind here. This fallbacks to the cache only when network is not available. But if you are on a 2G connection, that's very slow. So this will take like huge amount of time. Or if you are on, I don't know, some slower than 2G. So this will be very slow. So the same thing, this is the code. The same thing, but maybe better, is cache than network. And this is how Twitter works. So basically, when you open your Twitter application, you will get immediately some data. But when the data is updated from the network, you will just get the see new posts at the top of your application. When you click, you will scroll up. And that's perfect for that kind of situation. So even if you are offline, you will get the list of the tweets that are cached for you. If you have connection, the new one will be loaded without interrupting your user experience part. And that's how it works. There is a little more code here because we need to check, is data available? If we start receiving from the data, we can put some loading things, fetch the cache data. Once we get the data from the network, update the data and show that to the user. The service worker is, again, it's simple. Just when you get things from the network, update it. That's it. And of course, we need to have some kind of generic fallback. Sometimes the cache doesn't work, network doesn't work, and we said we don't want to show dinosaur. So we need to show something like offline image, or we want to show offline HTML file, which is also cached, and things like that. We just want to inform user in more friendly way that nothing is available for him and that he cannot use our data. This is the great example of that user experience. So basically, this is how application for flip cards looks when you are online. But if we turn the application, if we turn the network, it goes gray. And you see here you are offline. But if you open some article before, it will be stored in your cache and it will be in color. So for example, if I load this article or product, whatever it is, before, this will be blue and all others will be green. So when you are offline and you are clicking, you know how to get the data that you have already. Of course, for these examples, I use the vanilla JavaScript, like no libraries, no frameworks. But Java Workbox is JavaScript libraries that adds offline support for the apps and takes some best practices and removing the boiler codes that developers write. So this is the conclusion for a reliable thing. Like we need to design for success, and we need to have in mind that our users don't have reliable network, but we need to have reliable application for them. We need to build fast applications that works offline because that's the ultimate goal of user experience. And we need to inform users about the states. Like if they are offline, you saw the example before. Here, you need to inform them. You are offline. You don't have full capability of your application. And if you want to play with service workers without writing some of them and see code examples, this is serverworker.rs. And there is a lot of examples that you can just try with push notifications and all other things. And this is your ultimate goal, to provide good experience that lessens the impacts and change of the connectivity. And that's the rule number one. The apps needs to be engaging. This is the new thing because we didn't have, like 2 years ago, we didn't have push notifications for our web apps. But if you are using Twitter on your desktop or mobile web or Facebook, you are probably getting the push notifications. WhatsApp has also the push notifications. A lot of applications have them. The engaging apps are charming and attractive, and it gives our push notifications are more powerful than newsletter or some things like that because they are giving ability to keep users engaged, to call them to come back to use our app. And that's the biggest power of native apps. And this thing is also powered by service workers. So this is how it actually works. You need to enable them, that's okay, because you cannot send push notifications to the users if they don't want that. And then you have the same push notification as you have in your native application. You will see here, it's the same way. It's the same thing, actually. So this is some funny picture, like the guy is getting a lot of push notifications and he's annoyed with that, but he doesn't want to turn them off because probably he has feeling that he will miss something out. So, but good notification. This is new for web developers. That is the way why I'm trying to get clear how they look like. They are timely, they are precise, and they are personal. They need to be in exact time related to you, and they need to be like, I want to have this. So this is the example of good applications. If you are traveling, it's like send message in response to traveler booking a flight, send message in response to listener playing the music, send message in response to shopper viewing an item. Or flights if your Uber is arriving, on things like that. They work in the same way as native applications. So you will need to set up your server. Server will send some push notification to service worker. Service worker will raise notification to your web app. And it can, once the notification is clicked, you can send some request to server and said like this notification is read, or download some data, or whatever you want. How Twitter works actually in a progressive web app, once you receive the notification, that means you are online. So Twitter immediately downloads the tweet that is related to notification. So even if you go offline and click to the notification, you will get that data available to your application. And this is how it works. So push message is sent to the service worker. Service worker show the notification to our mobile app, and then we can do whatever we want. We can load things from the network. We can put them in a cache, basically whatever you want. This is the code. So on a push, do something. And of course, when notification is clicked, do something else. So you have full control of that. And this is the JSON file that describes the notification. We can have actions, like in native apps. Do you want to pay something? Do you want to go to, what clicks means, do you want to go to that tweet, or you just want to close notification? You can have some pictures and things like that. The most important thing about this is that 43% of the people agree to allow push notifications. So this is very, very powerful tool. Just don't abuse that. And this is one trick. So basically, in the web, you saw probably near your address bar of your website that sometimes you get allow or not allow push notification. If you click not allow, you will never again see that message because user needs to go to the settings and change that. So what all clever people do is that show some of your custom pop-up message. Do you want, when you see that your user is engaged, do you want to receive some notification? If you click not, nothing happens, and you can ask this again. If you say sure or allow, you will get that message on the address bar and you will accept that. Some tools for progressive web apps, including the service worker. Actually, it's one tool which is very good. It's Lighthouse, made by Google. You can use it as a tool in your browser or as a plugin for Chrome, and it will test your website. So I did the test for conference website. So as you can see, they invest a lot of time in SEO things, but progressive web apps and performance are not the best one. So if we scroll down, we will see all the stats about apps, what can be improved, how it can be improved. This is the part of progressive web apps. It will go back so we can see what can be improved and what is already done. And you can just follow this and you will improve your website performance like hugely. And you don't need to aim to have all hundreds, like if it is all green, it's already good enough. I have 1 minute, so I will jump to some showcases. So for example, Twitter Lite, when they use progressive web app techniques, they increased 65% in page precision. They increased 75% percent of the tweets sent, and they decreased 20% of the bounce rates. We are talking about millions of users. Alibaba increased conversions across the browser for 76%, and they got 44 times higher interaction from ad to home screen. They also increased the usage of native web apps. Book My Show, they got 80% in conversation. The application was 54% smaller for downloading, and they have 120% smaller app for iOS store. And this is actually one of the best progressive web apps use case that you can find. There is a huge article on a Medium, but they reduced their download time from 12 seconds to 4.6 seconds. They used React for building this with progressive techniques, and it's amazing article. You should read that. Also, Uber, Lyft, Google Maps, they all started to produce progressive web apps. There are some myths about progressive web apps. They are only for offline apps. It's not true, because all these things can be used on a regular desktop web, so they are not just a mobile thing. They are Google-only thing. That's not true again, but the Google is doing a lot of work to make them popular and to move them forward, but actually the idea was here. So, the Steve Jobs, when he presented the iPhone 3, he said that he had idea about using web apps on the mobile apps without App Store and things like that. Unfortunately, Apple has the worst support for progressive web apps at the moment. So progressive are not ready yet, partially. In Safari, on iOS, they are not, because you don't have push notifications. You don't have add to home screen, so two very important features are not ready, but they are moving that forward. This is the current statistic. So service workers are available to all major browsers. And fun thing is that we always hate Internet Explorer things, but Edge is actually super modern browser which supports almost all the things that Chrome do. So it's like really good. Regarding the payment request API, as you can see, that is not production ready, but Chrome is moving that forward, so that's something that will happen in the future. Push API, as you can see here, Safari and iOS Safari don't support that. Same for Web App Manifest. If you want to see some cool progressive web apps, this is a nice website, but you have many of them. And this is just the summary of things that are available in the browser. Browser is amazing machine at the moment. So you can talk with any things regarding the hardware. Of course, you cannot access to some Bluetooth, NFC things and things like that, but you can access to the camera, to geolocation, to things like that. And just I want to close this talk with this video. It's like, I'm not like any kind of evangelist of progressive web apps. I'm like interested in technology, so always depends on your project. So progressive web apps are not the answer to all problems that we have, but it is possible to build great progressive web app, and this is the example of that. So, almost double. Okay, so to conclude all these things, don't be driven with any type of hype in any kind of project, any kind of technology. Just choose the best fit for your project. And this is not in any kind, this is not about progressive versus native app. It's about delivering the great user experience to the users. And that's the most important thing. And choose your technology in that way for your projects, not like progressive web apps are hype. We even don't know will they exist in 2 years, so who knows. Thank you.
Thank you all. We don't have time for the questions, but you can talk with Antonio during the break. And I'm now calling you to
Can we have one question? I will give some tickets for the conference.
Okay. Then just one quick.
Yeah, one quick question. Okay. He was faster.
So could we cache some post requests with the service workers?
No, only GET requests.
Okay, so this is some disadvantages for PVA or?
But I don't see that as disadvantages because post needs to change something on a server, so that's not disadvantage.
But what if you just want to store some data or a form offline and then you want to resubmit it?
You can do that, but with a sync event. Yeah. Okay, so you have a ticket for the conference. For all other people, we have 20% discount with GrowIT code. The organizers tweeted that already. If someone wants stickers, I have enough stickers, and I hope it was interesting. Thank you for your time.
Thank you once again, and they are waiting for you.